This lesson is coming from section 3.2, and it's on page 224. And the problems in this group, we're going to have to use the book to be able to explain it to you. So here's problem number 11. All right, let me see if I can get that to focus. Okay. Alright, so we're going to use this graph to answer these questions. The first one says find f of 0. That means if x is 0, what is y? So you need to come to the graph and find the point where the x coordinate is 0, and then your answer is 3, because that's the y coordinate. The second part of that is f of negative 6. So you come to the graph where the x coordinate is negative 6 and your answer is negative 3. So all of these are just reading straight from the graph. Alright, part B, find f of 6. So you're going to go to the graph to find the point where the x coordinate is 6 and your answer is the y coordinate. So your answer for this part right here, f of 6, your answer is 0. And then for f of 11, that means when x is 11, what is y? So you come over to where x is 11 and your answer would be 1. Alright, part C. Is f of 3 positive or negative? Well, they don't have a point labeled 3, but you can count over 1, 2, 3, and then go up to where you intersect the graph, and the question is that y value a positive number or a negative number? Well, you might not be able to tell exactly what it is, but you can certainly tell that it's above the x-axis, so it's a positive number. So this answer would be positive. Part D, is f of negative 4 positive or negative? So again, you come to where x is negative 4 and go until you intersect the graph, which is right there, and that would be a negative y value. So that answer is negative. For what values of x is f of x equal to 0? It means what is the x that makes y 0? Okay? Find the x values for which y is 0. Well, y is 0 right here, so one of the answers is negative 3. Y is 0 here, so one of the answers is 6. And y is 0 here, so one of the answers is 10. So this part has 3 answers, negative 3, 6, and 10. For what values of x is f of x greater than 0? Meaning, for which x's is y positive? Well, y is positive with anything that's above the x-axis. So that would be all of this part and this little part right here. So how are we going to write that? We're going to go, it doesn't say equal to 0, it just says bigger than 0. So we can't count negative 3, but that's where we have to start. So all the x values from negative 3 up to 6, but not including 6. So that would be written negative 3 to 6 in interval notation with parentheses, because it doesn't have the equal to 0. Then we also have to include this part right here. So we've got to start at 10, and that's going to be with a parenthesis, because at 10 it's actually equal to 0. Then we're going to go to 11, and we're going to put a bracket, because the 11 number is actually included, because the y value is positive. So we're going to say from -3 up to +6, and then from 10 to +1. And we don't keep going because the dots on the end means this graph is all there is. It doesn't keep going any more than what you can see. Alright, what is the domain of f? The domain means what are the x values? Well, the smallest x value that we have is -6, and the largest one is 11. So the domain, the x values, range between -6 and +11, and both of those numbers are included, so you would write it as -6 to 11 inclusive with brackets, since they're both included. What is the range? The range means what are the y values? What part of the y-axis is used in this graph? Well, I can see that right here it's going to start at -3. That's the lowest point. And what's the highest y value is 4. So my y values, that's my range, go from -3 up to 4. And it includes both of those. So I write that as -3 to 4, both of them with brackets. Part I, what are the x-intercepts? Well, that's where it hits the x-axis. Those are going to be the same exact answers as what makes y 0, because remember, that's how we find x-intercepts, is to let y be 0. So the answer to I and the answer to E are the same thing, -3, 6, and 10. The y-intercept, there's only one, and where does it hit the y-axis? When y is 3. So that's 3, or the 0.03. When you're looking at My Math Lab, be sure to check, do they want you to write the answer as an ordered pair, or do they want you to write it as a single number? Up here, for sure, it's a single number. You just list -3, 6, 10. But here, the directions could say, write it as an ordered pair. And if that's the case, then you'd write the whole ordered pair, -3, 0. Why did my recording stop? Oh, there it goes. 6, 0, and 10, 0. The recording paused for some reason. I don't know why. Alright. That was x-intercept, y-intercept. We've done that. How often does the line y equals 1/2 intersect the graph? And so what we need to do is think about, where is the line y equals 1/2? So here's where y is 0. Here's where y is 1. So y is 1/2 right there. So if you extended that line in both directions, how many times would it hit the graph? 1, 2, 3. So that one is 3. How often does the line x equals 5 intersect the graph? So go to where x is 5. Remember, x equals is a vertical line, so that would be only one time. So that one's 1. For what values of x does f of x equal 3? That means find the x that makes y 3. Well, where is y 3? When x is 0 and when x is 4. So that would be 0, 4. For what values of x does f of x equal -2? Well, that would be, find the x that makes y -2. So -2 would be right here. One of the values is -5, and one of the values is +8. Those are the two values that make x equal -2. Okay? Now, we're going to do number 12 because it's the same kind of problem, and I thought an extra practice would be good. So, the question is, find f of 0. That means let x be 0. What is y? So, I'm seeing right here that that answer is 0. What is f of 6? Meaning let x be 6. What is y? And I see 0 there as well. Find f of 2. If x is 2, what is y? Y is negative 2. Find f of negative 2. Let x be negative 2. What is y? 1. So this answer right here would be the number 1. Is f of 3 positive or negative? Well, I go to where x is 3. That's right here. Come down till I hit the graph, and I can see that's a negative y value. So that one is negative. Is f of negative 1 positive or negative? Go to where f is negative 1. Go till you hit the graph, and you can see that's a positive number. So that would be positive. For what values of x is f of x equal to 0? That means find the x that makes y 0. Well, y is 0 right here. Only one time, and the x value is also 0. For what values of f of x less than 0? That means find the negative values. Well, the only part that's below the axis is this part right here. And it starts when x is 0, and it ends when x is 4, but we don't want those 2 points because it actually makes it 0 there. So that's why you have to do from 0 to 4 with parentheses, because it doesn't actually include the 2 endpoints. Alright, where are we? What is the domain? That means, what are your x values? They go from negative 4 up to 6 and includes both of those. So that would look like negative 4 to 6. What is the range? That means, what are your y values? Y is between where and where? Well, the smallest y value is right here when y is negative 2. You see that? Y is negative 2. And the largest y value is when y is 3. So the y values go from negative 2 up to 3. And it includes both of them. So you do it like that. Be sure when you write range values that you go from bottom to top. You always go from smallest to largest when you write things in interval notation. Okay. That was the range. What are the x-intercepts? Well, where does it hit the x-axis? Right here, right here, and right here. So if they wanted them as ordered pairs, you would write 0, 0, 4, 0, and 6, 0. Like that. That's the x-intercepts. The y-intercept is that single point 0, 0. So it would just look like that. How often does the line y equals negative 1 intersect the graph? Well, you remember y equals is a horizontal line. Go to where negative 1 would be and draw a horizontal line. How many times does it hit the graph? 2. How often does the line x equal 1 intersect the graph? Go to where x is 1. Draw a vertical line because x equals is a vertical line, and it hits the graph only one time. For what value of x does f of x equal 3? That means find the x that makes y 3. So I'm looking up here for when y is 3, and my answer is 5. That's the value that makes y 3. And then the last question on this part is, for what value of x does f of x equal negative 2? That means, for what x is y negative 2? Well, y is negative 2 right here, so my x value would be positive 2. Alright, now the next group of problems, let's look at the directions. Determine whether or not it's a function by using the vertical line test. I'm going to tell you what that is. In either case, use the graph to find the domain and the range, the intercepts, and any symmetry. Alright, it is a function if, when you draw any vertical line, it only hits it one time. This one is not a function. If I draw a vertical line, I hit the graph 2 times. That means it does not pass the vertical line test. To pass the vertical line test, a vertical line can only hit the graph 1 time. This one is a function because any vertical line, no matter where you draw it, is going to only hit that graph 1 time. This one's a function because a vertical line only hits it 1 time. This one's a function. This one's not a function. You can draw a vertical line and make it hit it twice. This one's not a function. This one is. This one is. This one is. It looks funky, but when you draw a vertical line, it only hits the graph 1 time. This is a function, this is a function, and this one's a function, this last one. So if it hits the graph more than 1 time, it is not a function. Okay. Now the other thing we need to make clear is that when the graph has arrows on it, it means it continues on in that same pattern that's been indicated. But if the graph has dots on it, it means that's all you get. What you see is what you get. So this graph doesn't continue on. And so we're going to look at this one and write the domain and the range. Well, the domain is what are the x values. The x values go from negative pi to positive pi. Now, when I looked at this on my math lab, it was sometimes hard to see. So if that looks like some kind of a symbol that you don't recognize, it's probably pi. These are part of trig graphs, and they're really important in trig, but they're just throwing them in here to test domain and range. Alright, so when you write that domain, it goes from negative pi to positive pi. So you write it like this. Okay, so that's your domain. And it includes both points. So you have brackets on both points. Alright, for the range, we have to talk about what's the smallest y value and what's the largest y value. So the range is from negative 1 to positive 1. Remember, you go from bottom to top. Intercepts. Well, it has an x-intercept right there at negative, sorry, this is an ordered pair, so it's a parenthesis. Negative pi over 2, that makes y 0. It has another one at positive pi over 2. Those 2 points right there. The y-intercept is this point, so you would write that one as 0, 1. So on the question, what are the intercepts, you would list all 3 of those ordered pairs. Does it have any symmetries, x, y, or origin? You can see if you fold this one across the x-axis, across the y-axis. If you fold it, if you could pick it up and fold it across the y-axis, it matches itself. Therefore, it has y-axis symmetry. Okay? Now we're going to go to problem number 17. Let me see if I can show you the answers and the problem at the same time. Okay. So the first thing we're going to do is note that this one has arrows. That means that it continues on in this same pattern forever and ever. Like this. It's just going to keep on going and keep getting wider and wider. And we've already said this is not a function because it doesn't pass the vertical line test. But the problem asks us to still talk about the domain and the range, etc. So the domain, since it keeps going forever, the smallest x value that's used out here is negative infinity. And you always use a parenthesis with negative infinity. And the largest x value that's used is right here. That's when x is 0. So that's your domain. Now, for your range, as this thing keeps going, it's going to use up all the positive values of y, and it's going to use up all the negative values of y, because it's going to keep going. So there's not a way to box it in to say all the y values come between here and here. You can't do that on this one, because when it keeps getting wider, it keeps spreading out. Therefore, the range is all reals, which you write in interval notation like that. Then for the intercepts, there's only one, and it's the ordered pair 0, 0. That's both the x-intercept and the y-intercept. And then for the symmetry, if you fold this one across the x-axis, it matches itself. So this one has x-axis symmetry. Okay? Now, the last one we're going to look at is number 19. Now, let's look at how this is drawn. Yeah, y'all can see that right there. You see this arrow? That means it's going to keep coming down here, but it's going to approach this line, what we call an asymptote. It means it's going to get closer and closer and closer to it, but it's never going to cross over that. And then this open circle means it stops right here, but doesn't actually include that point. So for the domain, since this one gets closer and closer and closer and closer, but never makes it to the y-axis, it never touches the y-axis, the domain starts at 0, but it has to use a parenthesis, because it never actually intersects that y-axis. And it goes up to 3, but you see that's an open circle. So we have to use a parenthesis there. So this domain goes from 0 to 3. Now, what about the y values? The range. Well, as this thing keeps coming down here, it's going to use up all the negative y values. And the highest y value is up to 2, but not including 2. So your range, you do negative infinity to start down here and go up to 2, and you put a parenthesis since it doesn't actually include that point. There's only one intercept, and it's right here, and you can read that order pair is 1, 0. There is no y-intercept because I told you it never hits the y-axis. This graph just comes and gets closer and closer, but never touches the y-axis. And then is there any symmetry? If you fold it across the y, it doesn't match. If you fold it across the x, it doesn't match. It doesn't match itself through the origin. So this one has no symmetries. Okay? Now, that's all we're going to do in this assignment. So this assignment only actually has 5 problems, so it should be pretty quick for you and hopefully pretty easy. But you know, I'll be glad to help you on any of them if you'll just reach out to me.